from your notes, we're starting a chapter on polynomials, studying their graphs. We're going to do lots of factoring and finding asymptotes and holes and breaks in graphs. We're going to be multiplying and dividing polynomials. You guys are going to learn a lot of new things and stuff that you guys have never done before. So constant functions are degree zero. This is stuff that you guys talked about last year. Constant functions are functions that are of degree zero. So for example, f of x is equal to 5. That really means 5x to the 0 power, so we say it's degree 0. Linear functions are functions that are of degree 1. F of x is equal to 2x minus 7, which really means 2x to the first power minus 7. We call it linear. You guys should be able to look at that and tell me it's linear anyway. So quadratic functions, quadratic. Even though quad normally you think is 4, you guys should be comfortable enough knowing that that's actually degree 2. For some reason in math, a long time ago, someone decided to call degree 2 functions quadratic. So f of x is equal to 2x squared plus 3x minus 5. All right, the general form of a quadratic function. F of x is equal to ax squared plus bx plus c. Here's the graph of a quadratic function. It's a parabola. You guys probably know that already anyway. Parabolas, quadratic functions are parabolas. They are always symmetric to its axis of symmetry. So regardless of where the parabola is, there's always going to be a line that you can draw right through the middle of the parabola, and it's called its axis of symmetry. Its vertex is the high or the low point on the graph. It also falls right on its line of symmetry. If the a value, this a value right here, is greater than 0, you guys already know this. The graph opens up. In other words, the number in front of x squared is positive. It opens up. If it happens to be less than 0, then it opens down. So negative values mean it open down. Stuff you guys already know anyway. Standard form. And we're going to practice today putting things in what we call standard form. Standard form of a quadratic function, f of x is equal to a times x minus h squared plus k. Now that seems awkward, maybe, but we're going to practice. You've done this before, but we're going to build on that today. The axis of symmetry is the vertical line x equals h, and the vertex is the point h comma k. So let's talk about what that means. Here's standard form for a parabola. We're going to talk about how you get the a value here in just a minute, but x minus h, quantity squared plus k. That negative h right there and this k right here are the numbers that you look at in order to get the vertex of the graph. And it's always the opposite of, it says minus h right here, it's going to be a positive. If it says plus h, it's going to be a negative. So it's always the opposite of what shows up in the parentheses for the h value. And then this number added at the end, that's the k value. In other words, the y value of your vertex. And I wrote that right here. It's h comma k. Now, if you graph a parabola, and let's say that that parabola opens up like this point right down here at the bottom, that point is called the vertex. And that vertex, as we just said, comes from h comma k. Well, the axis of symmetry is the line that cuts that parabola right in half. And it's always going to go right through the vertex. Well, this line right here is a vertical line, and you guys know, hopefully from last unit, that vertical lines, the equation of a vertical line is always x equals whatever number it is, wherever it crosses the x-axis. Well, in this case, where does it cross the x-axis? Crosses right here at h. So x is equal to h. That's where that comes from right here. The line of symmetry, the axis of symmetry is always the x value of your vertex. Yes? All right, an example. 3 times the quantity x minus 2 squared plus 7. The axis of symmetry, actually I'm going to do the vertex first. The vertex is the opposite of minus 2, so it's a positive 2. Then it's that number added at the end, 2 comma 7. The axis of symmetry is the line that goes right through the middle of the parabola. So in this case, it's going to be x equals, why is it a 2?
It's the same.
It's the same as the x value from your vertex. So these two numbers are always the same. So once you, I think it's easier to come up with your vertex first. Your axis of symmetry is going to be exactly the same thing. All right, examples, and you guys have not seen this page yet, so please, you need to start writing. Finding a vertex. Label it finding a vertex. You have to start, you know what, even if you were going to print the notes off later, I think it would be a good idea to be working on these things together with us. F of x is equal to x squared plus 6x minus 11. Right now, this parabola is not written in the form that we need it to be written in order to find the vertex. So what we're going to do is move things around. So we have x squared plus 6x. Notice I left this huge space, and I put a negative 11 at the end, and I'll explain that in just a minute. To do this, remember how we need our equation sheet. We need our equation to look like this: x minus some h value squared. Then we have to have something written at the end. Well, right now, we don't have some quantity squared, some value in parentheses squared. We have an x squared, but we don't have some x minus h value squared. So what we're going to do is make that happen. So we have x squared plus 6x. We move the minus 11 over. But now in the middle here, you guys will notice I have a plus 9 minus 9. Where did that come from? And this, maybe you have some recollection of having done last year. This plus 9 minus 9 came from taking half of 6. I'm going to put a little note here, probably a good idea for you guys to do that too. Take 6 and divide it by 2. Take 6 divided by 2. What's 6 divided by 2? 3. All right, and then you square the 3. 3 squared is equal to 9. 3 squared equals 9. So I added 9 there. Now, hold on, because I'll still tell you why I did that. We added 9 here, but it's illegal to just add 9 in the middle of an algebraic expression. So if you add 9 here, you have to take it away. And you take it away because you really want to have added nothing. If you add 0 to an expression, that doesn't change the value of it. So if I add 9 and then subtract 9, I've really added nothing. But the reason I did that was because these 3 terms now have created what we call a perfect square. So notice my parentheses here. We have a set of parentheses, and we're going to square it. That's what I need it to look like. Remember, I needed it to look like that up here in order to find my vertex? So if I have x squared plus 6x plus 9, this is what we call a perfect square, and we can write it as some quantity squared. So x squared plus 6x plus 9 can be written as x plus 3 squared. So where did the 3 come from? Where did the plus 3 come from? Well, it came from right here when I took that 6 and divided it by 2. That goes right there in the parentheses. And then at the end, I had that minus 9 and minus 11. Those two things combined give you minus 20. So we have x plus 3 quantity squared minus 20. Well, what is the opposite of plus 3? It's a negative 3. So that's the x value of our vertex. And remember, that number doesn't change. It stays a negative 20. So our vertex is negative 3 comma negative 20. The negative 3 is what we call the h value, and the negative 20 is what we call the k value. So h and k from up here in our form for finding the vertex of a quadratic. This one right here, x squared plus 8, x squared minus 8x plus 3. So the first thing you do, following your steps, you write down the x squared plus 8x, you leave a bunch of space, and you put your plus 3 at the end. And now you're going to create your perfect square. And you create your perfect square. What did I do over here? I took half of
6.
So over here I'm going to take half of
Negative 8.
negative 8. Take half of negative 8. When you take half of negative 8, I'm going to do negative 8 divided by 2. That gets you negative 4. this is the part that always scares me, is that students will square -4 and get -16. But -4 squared means -4 times -4, which is a positive 16. This number right here is always positive, always, always, always positive. But you can't just add 16 in the middle, you've got to subtract 16 at the end, and then of course you have your plus 3. And then this x squared minus 8x plus 16, they create x minus 4 squared, and then you combine those two things at the end, it gets you minus 13. So the vertex is the opposite of minus 4, which is positive 4, and then that minus 13 doesn't change. And I think this is a good place to stop, obviously because of time, but also because, look at this next example, you guys. What is different about this? Yes, and that's going to change things a little bit, so we're going to have a little bit more work. That's new to you. You guys did these last year.